Hello and welcome to another Cashmax video. In this video we'll be looking at integrating using trig identities. I'm going to make this lesson in two halves. The first half is going to be focused on showing you where some of these identities come from, and the next half will be showing you how we use them with some questions. So grab yourself some paper and a pen and let's get started. Right, the first identity we're going to look at is this bottom one here, sine squared a plus cos squared a equals 1. But we're also going to use sine a over cos a equals tan a to help us get two more identities. So the first thing I'm going to do is divide both of these, well, all of these terms by cos squared a. And let's see what that gives us. So sine over cos is tan, so sine squared over cos squared is tan squared. So this gives us tan squared a plus cos squared over cos squared is just 1, and 1 over cos squared is sec squared a. Now if instead of dividing by cos squared I divide by sine squared, so divided by sine squared a, I would end up with, this would become 1 plus cos over sine, which is the opposite of sine over cos, so that will give us cot squared, is equal to 1 over sine squared, which is cosec squared a. So those are two new identities which are going to be really useful to us. And if you need to pause the video, copy down those two new identities, but also try and write down what it is that helped you to get there. The next identity we're going to look at is this one here. Sine a plus and minus b equals sine a cos b plus or minus cos a sine b. Now it's really important that you pay attention to the plus and minus here. Now whatever you have over here, you must have the corresponding plus or minus over here. So if you've got a plus at the top here, which means you need a plus here. If you've got a minus here, you need a minus here. Now you'll see with the cosine one and the tan one, they do flip around. So just be careful with those. Now, using this identity, what we're going to try and work out is what the sine of 2a is. Now, in order to make sine 2a, this would have to be a plus a, which means my b gets replaced with an a, like so. So let's just write down the results so far. We've got sine a cos b plus cos a sine b. Now, both of these terms here are the same term, but just written the other way around. So what we've actually got is 2 sine a cos b. So if you could write that in your notes, that would be brilliant. The next identity we're looking at is the tan of a plus and minus b. So just pay close attention to this. Okay, that says plus minus, that says plus minus, but this one here says minus plus. So when it comes to these identities, you must choose the corresponding sign when you're trying to use them. Right, so just like before, what we're going to try and do is work out what the tan of 2a is. So again, that would be a plus a, which means replace this with a and replace this with a, and what we get is tan a plus tan a divided by 1 minus tan a tan a. And what that gives us is 2 tan a over 1 minus tan squared a. And finally, we've got the cos of a plus and minus b, which is cos a cos b minus plus sine a sine b. So just like before, let's try and get cos 2a by replacing that with a. And what we get is cos a minus sine a, which equals cos squared a minus sine squared a. Now this particular identity is an important one because we can write down cos 2a in 3 different ways. So this is one of the ways we can write it down. But what we can also do is replace the cos squared with 1 minus sine squared. So if I was to do that, I get cos 2a. So I'm going to replace this with 1 minus sine squared using this identity. So that would become 1 minus sine squared a, take away the other sine squared a. So this is this bit here. And that gives me 1 minus 2 sine squared a. Alternatively, I could replace the sine squared a with 1 minus cos squared a. So cos squared a, take away 1 minus cos squared a. And if I expand the brackets and simplify that, I'll get 2 cos squared a minus 1. So like I was saying, the cos 2a identity is a really important one because it's used to integrate both sine squared and cos squared. And the other ones are used to actually simplify things to help you to integrate them. Okay, but please make sure you can get all 3 identities for cos 2a. Now, if you need to make a note of these, please make a note of them and how I got to them. And what I'll do is I'll summarize them all a little bit more neatly for you on the next slide. So there you have it. Those identities are going to be really important for you. Now, you need to bear in mind that none of these are going to be given to you in an exam. You will get the addition formula for the sine, cosine and tan, but you won't get these. So it's really important that you know how to get these. Even better still, if you can just remember them, commit them to memory, then that'll save you a lot of bother. But please don't forget the importance of being able to get to these identities, okay? Because they will be really important when it comes to integrating them. Now, there is one other thing you need to bear in mind, and that is how we use these double angle formulae. Okay, now you've got, for example, sine 2a equals 2 sine a cos a. All that means is for this identity, this angle here needs to be double these angles here. Okay, so for example, if I just chose sine 8a, that would make this 2 sine 4a cos 4a. If I made it sine 18a, that would be 2 sine 9a cos 9a. Even if I made it sine a, the other side would be 2 sine a half a cos a half a. So don't touch the numbers at the front, okay? So don't touch those coefficients. But all you need to remember is the angle on the left needs to be double the angle on the right, as long as you've written them the same way I have. Right, well, I hope that's helped. I am going to put this onto the start of the next video. Okay, I'll write them on the side somewhere, and then we'll do some examples and I'll show you how we can use these. So that's it for now, and I'll see you next time. Goodbye.